Welcome to this tutorial. I'm solving question number 6 of paper 2 October-November 2018. The topic of this question is radioactivity. The question says figure 6.1 shows a radiation detector placed on a laboratory bench. So we can see that there is a radiation detector over here which is connected to a rate meter which is showing the counts per minute of the radiation. The detector is switched on and 6 readings of the count rate are recorded. The table in figure 6.2 shows the readings obtained. So there are 6 readings: 31, 36, 29, 32, 31 and 33. Using all the readings obtained, determine an average value for the background radiation. Since we haven't placed any radioactive material in front of the detector, so the readings which are being taken at this moment are related to the background count rate where the experiment is taking place. Now to find the average, we have to add all the values here: 31 plus 36 plus 29 plus 32 plus 31 plus 33. So we are adding up 6 values. We would divide them by 6. So their sum comes out to be equal to 192 divided by 6. So it would be 32. The average count rate here, background count rate, is 32 count per minutes. In the next part it says figure 6.1 shows a point P which is a very short distance from the end of the radiation detector. A sample of the radioactive isotope cobalt-60 is placed at point P. So we have placed a radioactive sample of cobalt at this point, which is very near to the radiation detector, which means that if even alpha radiations are being emitted from this radioactive material, they would be easily detected by this detector, and beta and gamma are obviously detectable from a little larger distance too. Now, a sample of radioactive isotope cobalt-60 is placed at P. The average value of the count rate obtained is now 975 counts per minute. The average count rate is determined with different objects between the radiation detector and the sample. The table 6.3 shows the results obtained. So when no object was placed between the detector and the radioactive substance, the average count rate was 975. Then we place 4 sheets of paper between the detector and the radioactive material. So 4 sheets were placed here between the detector and the radioactive substance. The count rate does not decrease. Now remember, these 4 sheets of paper, they are able to block alpha particles if alpha particles are being emitted in this radiation. So when we place the paper and we noted that the radiation count is not decreasing, it means that the radioactive substance is not emitting alpha particles. So we can conclude here that alpha particles are not being radiated or emitted by the substance. Secondly, we place 0.5 millimeter thickness sheet of aluminium, and this thickness can easily block beta particles from the radioactive substance coming towards the detector. So we see a drastic change and fall in the count rate. So it shows that beta particles are being emitted by the radioactive substance. Thirdly, we have placed 2.0 centimeter thickness sheet of lead. This sheet would be able to block gamma radiation along with beta. So this was, the aluminium sheet was able to block beta particles, but gamma particles were able to pass through it. But when we are using 2 centimeter thickness sheet of lead, even gamma particles would be blocked. And the count rate we can see is further decreasing because gamma particles are being blocked. It means that gamma particles are also being emitted in this radiation. Now the next part says indicate by placing ticks in the appropriate boxes the radiation emitted by cobalt-60. So we are going to place a tick in beta particles box, and in gamma rays alpha particles are not being emitted. The radiation is produced when a nucleus of cobalt-60 whose mass number is 60 and proton number is 27 decays into a nucleus of daughter product X. Product X is not radioactive. Determine the number of protons in the nucleus of X and the number of neutrons in a nucleus of X. Now since cobalt-60 is undergoing beta and gamma radiations, so when it radiates, for example with a beta particle whose charge is -1 and mass is 0, then the product, the daughter nuclei which is being formed in this radiation process, its proton number is going to increase by 1 because one of the neutron is changing itself into a proton and an electron. So in a beta decay, beta negative decay, we have a neutron being converted into a proton and an electron which is a beta particle. So what happens? The proton number increases by 1, it becomes 60, but overall the mass number remains the same. So by seeing this equation for the process, we can write the number of protons in the nucleus of X as 28, and the number of neutrons in the nucleus of X would be mass number minus the proton number, so it would be equal to 32, and the protons should be 32 here. The next part says the half-life of cobalt-60 is 5.3 years. State what is meant by half-life. So we have to write a definition over here. We would write average time taken for the count rate to half. So the average time taken for the count rate to half is the half-life of a radioactive substance. In the next part it says when there is a lead sheet between the detector and the sample, the average count rate is obtained from 6 readings taken at 1 minute intervals. The 6 readings are given in the table below. So the first minute, after first minute, the count rate was 61, second 46, then we have 43, 56, 49 and 57. So we see a random pattern in the readings. Sometimes they are decreasing, sometimes they even increase. The later ones increase from the previous ones. There are reasons for suggesting that the variation in these readings is random and not because the number of cobalt-60 atoms in the sample is decreasing. If the reason of the variation was related to the number of cobalt-60 atoms decreasing, then the readings must have been constantly decreasing because the atoms are decreasing because of the radioactivity taking place. But since there is randomness in the readings, sometimes they are decreasing and other times they are increasing as compared to the previous readings. So there are some other reasons for this variation apart from the decrement in the sample of cobalt-60. State 2 of these reasons why there are variation in the readings. So one of the reasons is that readings are fluctuating. Sometimes they are decreasing and other times we are seeing an increase in the reading. The other reason for these fluctuations is that half-life is too long as compared to the observation time. Half-life is around 5.3 years here and the observations are being taken over a time period of 6 minutes only. So the fluctuation is also because of this, that the half-life at one hand is very long but the observations are being taken for a very short period of time. That is why there is quite a bit variation seen in the readings. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.